In this video, we'll continue our discussion of section 2.6 part 1 with homogeneous polar differential equations. I have two more methods to show that they are homogeneous. The first one, we didn't really even try the method. The method said put everything in terms of y over x. If you want to do that, feel free. You just have to manipulate the equation to make it where every input, anytime there's a variable, it's y over x. I don't like this. I think the way that this is, that we're about to do here, much quicker. Okay, so what this says, a DE, if it can be written in this form, if this is a homogeneous function of degree, whatever, n, and this is a homogeneous function of degree, same n, same number, then the DE itself is homogeneous polar. So if we can show that the top function is homogeneous polar, homogeneous function, and g on below, the bottom of the function, is homogeneous polar, then we can claim that the DE is homogeneous polar and use the methods we're about to go through. The last method is when it looks like this, it's the same thing except for the functions instead of f and g are m and n. So if you can put it in that form and show that those two are the same degree, then you're also showing that the DE is differential, or is homogeneous polar. Either way, it's the same way. We're going to do both. So let's take a look. I think some of these we are going to do twice. So we'll do one way and one the other. So let's take a look at our first example. I'm not going to go through this method here because we're going to take that way anyway. Yeah, let's give it a shot. Okay, so first example. So notice this is in that second form. So I'm going to recognize what each function is. M of xy is 4x squared plus xy plus y squared. All right, we want to show if that is homogeneous polar, so I'm plugging in tx, ty. So I got 4tx squared plus tx times ty plus ty squared. All right, we get t squared in each term. So we get 4x squared plus xy plus y squared. Well, that is t squared times our function. So m is homogeneous degree 2. So homogeneous degree 2. All right, so now I'm going to do n, which is my other function. That is negative x squared. You take the sign. This will be a lot quicker. Tx, ty. You can see that the square will come out, leaving me with a negative x squared. You can do that when it's that straightforward. That means this is homogeneous degree 2. This tells me, since those are both the same homogeneous function, same degree, then the DE is homogeneous polar. In your homework, on your test, you have to write it this way, something along these lines. If you want to write it more like in words, that's perfectly fine, but you can't do less than this. Like what I write is your bare minimum of what's allowed, like work shown on a test. Don't show any less than this. If you want to show more, that's great. Never show less than your instructor. Okay, so unless they tell you. Sometimes they'll tell you. Okay, so the method that was described above, they said let V equal y over x. This would be the case if we were going to if we were going to prove homogeneous polar by showing that we can write everything as m y over x. We're not doing that. So this would not be appropriate. I would do it this way. Y equals Vx. If you'd like to see an example of it done the other way, let me know. I can find a picture of one of the ones in the book and show you that. So I'm taking this. I'm going to take my derivative with terms of x. So dy dx, and then it's a product rule, v times x. The derivative of x is 1, so I just get v. Plus, now I take the derivative of v, which is 1, but I get the x, and then I don't know what v is, so I have to do dv dx. Right. The reason we do this is now we can put that equation up here in the right form and replace. So the equation is 4x squared plus xy plus y squared dx. and I'm going to add x squared dy to the other side. I'm trying to put it in the correct form. So this is dy dx, dividing both sides by dx, and then dividing both sides by x squared. We get 4x squared plus xy plus y squared over x squared. All right, the reason we did that is now notice the left side is what we had above here. It's this. So I'm going to replace that side with v plus x times dv dx. That's going to equal, all right, well, I have all this stuff. I'm going to replace any y's with the appropriate substitution here. I'm changing y. All right, so I leave the x's alone. 4x squared plus x vx plus vx squared all over x squared. All right, so notice everything has an x squared in it. So I'm going to divide out x squared. So I get v plus x times dv dx. And everything is divisible by x, so I get x squared. So I get 4 plus v squared. That's taking x squared out of everything on the right. I have it across the top and across the bottom, so they just cancel, each one of them. We can do that since there's only 1 on the bottom. If it was flipped where 3 were on the bottom, we couldn't do that. Okay, notice there's v's on both sides, so I can just drop them. So we get 4 plus v squared. Now, it may not feel like it, but this is separable. All right, so let's try to separate that. I'm going to multiply both sides by dx. I'll do it piece by piece here. 4 plus v squared times dx. I want the v's on one side, so I'm going to get 1/4 over v squared dv equals 1 over x dx. So it's dividing both sides by what's in front of the dv and dx. Now I will take my integral. The 1/4 can come out. I got v to the negative 2 dv. And then I'm leaving the 1 over x because I know that integral. We do it a lot in this class. All right, so I get negative 4 v. I raise it by 1. That's negative 1 and divide by my new one. Over here, I get ln of x plus c. And then now I'm going to multiply both sides by negative 4. So I get v to the negative 1 equals negative 4 ln of x. And then this was a c1. I'm just going to call it c now because if I take a constant, multiply it by another constant, it's still a constant. I don't have to worry about the sign. This is 1 over v is equal to that. I think we're almost to an answer. Remember that y equals vx. Well, v then would be y divided by x. So I can replace this. Y over x, negative 1, is negative 4 ln of x plus c. Well, that means just flip them over. So I got x over y, negative 4 ln of x plus c. I can solve for x here by just dividing by the whole right side and then multiplying both sides by y. So that gets me x divided by negative 4 ln of x plus c. Really, you could have stopped. I would have been completely satisfied if you would have just stopped here. Oh, I think we made a mistake somewhere. Oh, shoot.